I've been working in industry for a long time. I've worked in industry 15 years prior to starting my PhD. I worked on a variety of systems. I've done web programming, back-end programming. I was a Unix systems administrator for a while. And honestly, I worked at a company that used a distributed database. And we had to figure out which one to deploy. This was in around 2010 or so. There were a few options. And I ended up becoming more interested in the distributed database that we were deploying than the actual product that my company was building. So that's when I applied for a job at Basho, who made Riak, which was the database that we used. And I left my company to go join that company instead. Lasp is my PhD thesis, and Antidote is another piece of technology that came out of the same research project. And so Basho Technologies and my research group, which started before I left Basho to pursue my PhD, were part of a European-funded research project called Sync-Free. And Sync-Free's main goal was to make it so systems that had shared data could be implemented easier with less coordination. And so they address kind of two things: programming those systems, which Lasp addresses large-scale peer-to-peer application development, and Antidote, which is a database that's focused in smaller data center style deployments rather than peer-to-peer deployments for building correct distributed applications without weak coordination. So I think that having industry experience is good. A lot of researchers I know really want industry experience because they've spent all of their lives in academia, and a lot of them have confessed to me that they chase problems that end up not really being a problem that anybody cares about or will ever deploy. And so a lot of researchers really like academics who have come from industry for that perspective, also because they write much better code. That being said, coming from the industry side, sometimes I think a problem is really interesting because I see people, I saw people struggling with it on a daily basis, and sometimes it's just kind of like, well, you can never publish a paper on that because it's just too small of a problem or it's too incremental. And so I think it's a good place to be in, because having both sides of having the academic side and the industrial side allows me to kind of find problems that are researchy enough, but I know could be implemented by my friends working at companies in the Bay Area or whatnot. For both Antidote and Lasp, we are trying to achieve a pluggable backend. So Antidote relies on an append-only log, so there's only particular types of storage engines that would work for that, where Lasp stores objects, and so Lasp can run on top of any key value store, essentially. More practically, right now, Antidote is using a built-in persistence mechanism that comes with Erlang, and Lasp has support for a built-in persistence mechanism from Erlang as well as LevelDB. And there was a fork that was attempting to provide support for RuxDB as well. So we're aiming to use kind of industrial-grade storage engines. So Antidote takes advantage of some of the open source libraries that have come from Basho Technologies as part of Riak. But for the most part, the designs of the system are quite different. Antidote, for instance, partitions its data using a similar strategy and some of the same code as Riak, but Antidote has a transaction protocol and it has a different set of CRDTs than Riak does. And so a lot of that stuff that's kind of the core to why Antidote is unique, it all comes from our research group and doesn't come from any prior work by Basho Technologies. Antidote mainly focuses on a particular, so it's focusing on geo-replicated applications, and so kind of the main competitors in that space are Cloud Spanner, DocumentDB or CosmosDB as we saw at the conference, and things like, I guess, DynamoDB, for instance, or CockroachDB or FaunaDB. All of those offerings that are focused at the geo scale, the only one that does weak consistency out of that group at the geo scale is CosmosDB. And CosmosDB makes you pick a choice. And so for Antidote, we veer towards these applications that can be built on CRDTs. We get gains from that. That allows us to have a very clever analysis technique that determines when we need to coordinate. And so we're really looking for customers that have a strong geo case. They know that they can fit into this CRDT data model, and for people that are looking to experiment with something new and kind of challenge the norm. It's very difficult. This is the second time I've tried selling a database, and it's very difficult to get people to adopt a new database when the data model is different and the guarantees are different. So Antidote is deployable via Docker, so you can run it in Kubernetes or Mesos or something like this. You can run it on Amazon. It's been tested on Amazon. All of that works great. Antidote has a protocol buffer interface, so you could write a driver for it in whatever language you wanted. We have one in Erlang, we have one in JavaScript, and we want it in Java. So we figure we've kind of covered the broad set of the target languages. This gets us Scala, this gets us all the JavaScript things. You can do things from the front end, back end. And so, yes, for the application developer, everything they need is just bundled in a client library, and they don't need to know Erlang at all. So I really enjoyed the Cosmos DB talk. I was really interested to see it. It's a brand new offering, and it's kind of a competitor to the work that we're doing, right? So it's always interesting to see innovation in that space and people providing new technologies. And other than that, I'm going to do an internship at Microsoft Research on Orleans, and so I really enjoyed the Orleans workshop. So I'll have some knowledge coming out of the gate rather than showing up not really knowing what's going on.